Here are solutions to homework set number 1 for ECE 111. This homework set looks at kind of an introduction to Matlab, how to use Matlab with for loops, while loops, how to use Matlab as a calculator. Now the first problem is solve two equations, two unknowns. We actually haven't covered that yet. That's covered in week 2. But if you ever run into a problem where you don't know how to solve it, what you can do is go to Bison Academy. So here's Bison Academy, the semi-official website for the ECE department at NDSU. If you go under 111, this class, under homeworks and solutions, these have homework problems and solutions from the previous semesters. Go under homework set number 2, and problem number 2 is here. So here's the Matlab code that lets you plot the two functions together. Where the two functions intersect is the solution. That's something we'll cover in week number 2. For now, all I care about is here's the answer. The point behind problem number 1 is if you ever get stuck on a homework set and you don't know what to do, go back and see what we did the previous semesters. Now every semester I change the problems, so you can't just copy and paste. But the Matlab code, the procedure, the ideas are the same year after year. So it's kind of one way to get an idea of how to approach a homework problem. And one of the biggest problems with Matlab, along with any computer language, is trying to figure out what the commands are. Well, you'll get the list of the commands in the previous homework problems. Problem number 2 gets back to Matlab. It's find the roots to a polynomial using the function roots. Now, if I have a polynomial like this, if I plot it, that's a cubic. It's got, in this case, 3 zero crossings. The zero crossings are the solution to y equals 0. That's also the command roots in Matlab. The way you use the roots command is I take this polynomial and input it as a matrix. Matlab is a matrix language, and it's a whole lot easier inputting a matrix than a polynomial. What the matrix represents are the coefficients in decreasing powers of x. So this is 1x cubed minus 5x squared minus 196x plus 980. Find the roots to that polynomial, and here's the answer. Those are my 3 zero crossings. One's at minus 14, plus 14, and plus 5. Try that for a fourth order polynomial. A fourth order polynomial looks like this. In this case, I've got 4 zero crossings. Input the polynomial as a matrix in decreasing powers of x. So 1 minus 36x cubed, 469x squared, minus 2610x, plus 5200. That polynomial represents, well, this matrix represents that polynomial. Find the roots, and these are the zero crossings. It's at 13, 10, 8, and 5. Finally, part C, if I set this equal to 0, solve for x. Again, that's the roots command. Input the polynomial in decreasing powers of x. 1x to the 5th, minus 5, minus 77, 641, 480, minus 6300. Find the roots of that polynomial. A fifth order polynomial looks like this. In this case, I actually have 5 zero crossings. Minus 10, minus 3, plus 5, plus 6, plus 7. Problem 3 looks at using Matlab as a graphing calculator. Now, problem 3 is just using Matlab as a calculator. If I have a function, I can calculate r in terms of t. So if I know that t is 10, I'm going to say t equals 10. Okay, kind of arbitrary. I'm using a variable name that matches the problem. Kind of voice confusion, but Matlab doesn't care. The resistance is almost the way you write it. It's 5,000 times the exponent, that's 10 to the x, 4,100 divided by t plus 273 minus 4,100 over 298. You need these parentheses. If I take them out, I'll do 4,100 divided by t. Take that answer, add 273. With the parentheses, it adds 273 first, and then takes the ratio. So R is 10,368. The voltage, I can have a function of a function. Once I know R, calculate the voltage. will be 4.19 volts. Change temperature at 30 degrees Celsius. Same equation for R. It's now 3,900 ohms. Same equation for V, 3.32 volts. And you have Matlab being used no different than a hand calculator. Problem 4 uses Matlab as a graphing calculator. Suppose I have same equation. I've got temperature, resistance is a function of temperature. If I'm at 1200 ohms, 12,000 ohms, what's the temperature? 6,000 ohms, what's the temperature? How do we go backwards? One way to do that is to graph it. So I'm going to have temperature go from 0 to 50 degrees Celsius, steps every 0.1. So here's 501 points in that matrix. Calculate the resistance at each point. Now here I'm using the dot notation. If I take out the dot, Matlab is going to try to do a matrix inverse. The dot tells Matlab, don't do that. Treat these as 500 separate numbers. Do each calculation separately, which is what I want. Do the calculations at 0, 0.1, 0.2, 0.3. Grind out all 500 calculations and throw them in a matrix. When I'm done, I can plot temperature versus resistance, label the x-axis, label the y-axis, and here's what you get. Graphs are really common in engineering. What the graph tells you is this is the same as that equation, just a graphical version of it. What I can use a graph for is if I know the temperature at 15 degrees, here's the resistance. At 30 degrees, there's the resistance. Given R, find T. I can also go backwards. At 12,000, here's the temperature. At 6,000, here's the temperature. And roughly, that's about 7 degrees Celsius. This is about 21 degrees Celsius. Hard to read it off a graph to more decimal places. Next week, we'll look at how to get more decimal places using numerical methods. For this week, just use a graph, and that'll tell you pretty much what the temperature is given resistance. One other comment on your homework sets, I kind of ask that you do use these semicolons. What that semicolon does is it tells Matlab, do the calculations, but don't print out the results. If I take that out, I'm going to get 500 different numbers. It's not wrong, it just really messes up the display. I have to scroll through 500 numbers, which I don't care about. The 500 numbers is the same information as this graph. That's part of the reason for using graphs in engineering. I've got a bunch of data I want to display to the reader in a way the reader can understand. Giving them columns and numbers, at least for me, doesn't really help. The graph is a much easier way to give out the same information in a more meaningful way. Problem 5. Suppose I know the voltage. If I'm at 4 volts and 3 volts, what's the temperature? Well, I calculated resistance before. The voltage is a function of resistance. So type that equation into Matlab. Again, I have to use the dot notation, telling Matlab this is an element by element operation, not a matrix operation. Plot temperature versus voltage, label the x-axis, and here's what it looks like. What this tells you is, given the temperature, I can tell you the voltage, or going the other way around, given the voltage, I know the temperature. If I'm at 3 volts, here's the temperature. Next, for loops. Matlab actually is a programming language. It has for loops, if statements, while loops. What a for loop does is it repeats the code a fixed number of times. For example, suppose A is rolling 4 8-sided dice, taking the total. B is rolling 3 12-sided dice, takes the total. What's the chance A is going to win at any given game? If highest total wins, A wins on ties. Now to write this code, I don't write the entire code all at once. What I start with is just let's play a single game. I'm going to roll the dice for A, roll the dice for B, take out the semicolons, make sure the code works, and then check. If A is greater than or equal to B, I won, otherwise I lost. Run this code over and over again until I'm convinced that this works. Once I'm convinced the code works, add the semicolons, and I'll place that in a for loop. I'm going to play the game 5 times, and see let's play the game one time, and I'll play it 100,000 times and see how many times A wins. When I'm done, A won 39,000 times out of 100,000, or 39%. There's never a tie. B wins 60%. So these numbers change every time I run it. It's random, but that tells you roughly the odds of A winning. The odds of A winning is roughly 39.8% chance. That's for a single game. Change the problem. In number 7, suppose instead I play a 5-game match. So here's problem number 6. Play a single game. Put that in a for loop. I'm going to repeat, play the single game 5 times. If after 5 times, A has won more games than B, then I won. If they're equal, I tied. I'm never going to tie. Otherwise, I lost. Once I play a single match, put that in another for loop and play 100,000 matches. When I'm done, A won 31,000 times out of 100,000, or 31% wins, 0% ties, 60% losses. So what's happened is a single game, A's got a 39% chance of winning a single game. A 5-game match, A's got a 31% chance of winning a 5-game match. A while loop. While loops are slightly different than for loops. A for loop plays a fixed number of times. A while loop keeps on going until a condition is matched, or until a condition fails. If I want to say you have to be up by 2 games to win, I'm going to play the game just like we did before. But then what I'm going to do is just have another variable. This is called AX and BX. How many games has A won? How many games has B won? Keep on going until the difference is 2 or more. That's a while loop. So if A wins, then B wins, A wins, then B wins. I'm back where I started. Keep on going until I'm either up 2 games or down 2 games. If after the match, if I am up 2 games, A won the match. Otherwise, I lost the match, and you're never going to have a tie. Once I get that to work for a single match, put that in a for loop, and repeat 100,000 times. So here A won 30% of the time, so win by 2 match, loses 69%. If I want to make it a win by 5 match, all I do is change this number. So win by 5 match, keep on playing until somebody is up 5 games, or down 5 games. Repeat, same code runs, and A wins 11% of the time. So that's kind of what Matlab is. It's just a calculator. It's a programmable calculator. I can write code and execute it. It's a pretty friendly language. It's probably a little bit cryptic to you right now. You probably struggled a little bit on homework set number 1. That's part of the reason this course exists. You're going to struggle at the start of the semester. Hopefully by week 5 or 6, you kind of get the hang of Matlab, and the code's much easier to write. That's the goal of the course. By the time you finish the course, hopefully you're fairly familiar with Matlab. So when you get to other courses in the ECE program that use Matlab, you can focus more on the course and less on using Matlab. It's a pretty nice piece of software, but really, all Matlab is, it's a graphing calculator. And that is homework set number 1 for ECE 111.